Hello, welcome. Today I am going to derive the trapezoidal rule integral a to b y dx is equal to h by 2 times y naught plus yn plus 2 times y1 plus y2 plus yn minus 1 it is, where h is equal to b minus a by n, where n indicates the number of subintervals in which the interval a to b is divided. Here, before I could derive the formula, let us assume that the function y is given by y is equal to f of x, which represents a curve. And now here the limits taken are x is equal to a to x is equal to b, and x is equal to a is a line parallel to y-axis passing through the point a comma 0, and similarly x is equal to b is a line parallel to y-axis and passing through the point b comma 0. Here these are the two lines AD and BZ, which are represented by x is equal to a and x is equal to b. Next, let us divide this area under the curve y is equal to f of x bounded by the lines x is equal to a, x is equal to b and the x-axis by some straight lines parallel to x is equal to a and x is equal to b. Here one such parallel line is BC, and this line BC is drawn parallel to x is equal to a, and the distance between these two lines is h. So therefore when it is x is equal to a, then b becomes x plus x is equal to a plus h. When this is a, this is a plus h comma 0. The coordinates of b are a plus h comma 0. And in the same way, one more h units distance is taken here. So when the distance one more h units is taken, the coordinates of e becomes a plus h plus h. So the coordinates of e are a plus 2h comma 0. These are the coordinates of e. And similarly, the coordinates of h are a plus 3h comma 0. In this way it continues. Suppose these type of n subintervals are divided, so then this y becomes the final one, and y is the point whose coordinates are a plus nh comma 0. These are the points, and a is the point a comma 0, and b is the point a plus h comma 0. So in this way these are the points. So now for x is equal to a, when substituted in y, that is y is equal to f of x is the given function which represents a curve. When x is a, y is equal to f of a we get, and for this f of a, the y value I am writing is y naught, y0 say. And similarly, when y is equal to f of x and x takes the value this a plus h, then say it is y1. Let us denote this value by y1. y1 is f of a plus h. And in the same way, when we take the point e, and here what are the coordinates of f? We have to find the coordinates of f are x coordinate is a plus 2h, and now y coordinate becomes, we have to substitute this value here. Let me say it is y2. y2 is equal to f of a plus 2h. These are the values. So now what are the coordinates of the point D? The point D becomes, whose x coordinate is a and y coordinate is f of a, and f of a is denoted by a naught, y naught, y naught. So D is the point a comma y naught, and C is the point, this is the point C, whose x coordinate is a plus h, and y coordinate is f of a plus h, which I have denoted it by y1. So I am saying this y1. So C is a plus h y1. In this way we get the points. So now finally, what are the coordinates of the point Z? So the point Z is given by y coordinate is b, and x coordinate is b, I'm sorry, and y coordinate is a plus nh. We have to take for f of a plus nh. F of a plus nh is equal to, say, yn. So I am denoting it by yn. So here relationship between b and a we get. So here the first interval we take it, the next b point we have obtained, and whose coordinates are a plus h comma 0. So now an increment of h is given. So finally here for this point y, an increment of a plus nh we get it. That means n times h is increased. So this b becomes, b is equal to a plus nh, or b minus a by n is equal to h, where n is the number of subintervals in which the complete interval a to b is divided. So okay, so these are the things here. So now next assumption is, here by drawing these parallel lines, the closed figure a b c d a, I am calling it a b c d, this is bounded by AD, which is a line segment, BC a line segment, and AB a line segment. But this side it is bounded by a curve CD. But if I imagine that this curve is a straight line, I am approximating this curve to be a straight line. So here when these divisions are more in number, then the points A and B will be closer to each other. In such cases, the curve can be assumed to be a line, a straight line. And when the gap h is more, then the error is more. When the gap h is smaller and smaller, this gap becomes narrower and narrower. So it becomes smaller and smaller. So for that purpose, in order to get good values or approximately nearly correct values, h should be sufficiently small we have to take by increasing the value of n. So here in this one, h is b minus a by n. When n is more and more, h becomes smaller and smaller. When h becomes smaller and smaller, these lines, they come closer and closer to each other, and here the curve actually existing one can be approximated to a straight line. And now if I take CD a line segment, then AD and BC are parallel to each other, and ABCD is a quadrilateral. So here in this quadrilateral, these two sides are parallel, so that's why it is a trapezium. Now I want to find the area of the trapezium ABCD. So area of the trapezium ABCD is trapezium. Say this is trapezium. Area of the trapezium ABCD is equal to, we know that area of a trapezium is half into h into a plus b. Generally we write it here. This a and this a are different. So instead of that one, I can take any other letter, say x plus y or any other one. So this x indicates, so here I am drawing a trapezium, I will show what are the values here I have taken. So this is x units say, this is y units say. So then in between these parallel lines, suppose h is the distance between the parallel lines, then the area of the trapezium is given by half h into x plus y, or in other words, the area of a trapezium is half into sum of the parallel sides into distance between the parallel sides. This is the area of the trapezium ABCD. So now here my aim is to find the area enclosed by the lines x is equal to a, x is equal to b, x-axis, and the curve y is equal to f of x. So this complete area below the curve, above the x-axis, and in between these two parallel lines, whatever the area is present, this area I have to calculate it. So to calculate this area, I have to add the areas of all these approximated trapeziums. So in order to add all these, so here I do it. So the first area is half times half h into this side, and here the coordinates of D, as I have already shown, the coordinates of D are a comma y naught, a comma y naught. So that means from C to D, this distance is y naught, and the coordinates of C are, C becomes a plus h comma y1. So this distance B to C, it becomes y1, which is f of a plus h, y1 means. So this one. So the area of the first trapezium is half h times y0 plus y1, y0 plus y1, plus I am calculating this complete area. I am denoting it by a, say. A is equal to half h y0 plus y1 plus half h, as the distance between these two parallel lines is also h, half h into y1 plus y2, as the length of the line segment EH is y2. So in this way, if I continue for all these n trapeziums, the area I have to calculate it, it becomes half h times y2 plus y3, and it continues and it goes up to half h times yn minus 1 plus yn. This is the area of this last trapezium. So when I take out common factors, so half h is common, so say h by 2, y0 plus y1 plus y1 plus y2 plus y2 plus y3 and so on, plus yn minus 1 plus yn. This I get it. So in this one, it is very interesting to observe that h by 2, y0 is present one time, so y0, but the remaining y's we can say they are present two times, but only yn is present one time. Just before this one, we have yn minus 2 plus yn minus 1. So yn minus 1 also occurs two times. So this yn is present only one time. So y0 and yn are present one time. So I am collecting y0 and yn in the beginning as first term and second term. And the remaining terms are y1, y2, y3, y4 up to yn minus 1. They appear two times. So that's why while adding, the sum becomes twice y1 plus y2 plus y3 and so on plus yn minus 1. This is the sum. So here the area under the curve bounded by x is equal to a and x is equal to b, and the x-axis is h by 2 times y0 plus yn plus 2 times y1 plus y2 and so on plus yn minus 1. But we know that the area under the curve y is equal to f of x bounded by x is equal to a, x is equal to b, and the x-axis is given by a is equal to integral a to b f of x dx, and f of x is assumed as y, so y dx. This we have studied it under area under the curves in integration. So now these two areas are equal, so therefore I can write that integral a to b y dx is equal to h by 2 times y0 plus yn plus 2 times y1 plus y2 plus and so on plus yn minus 1, where this h is given by h is equal to b minus a by n, where a and b are the limits of the integral given and n is the number of subintervals in which the given closed interval a to b is divided. So by taking n as large as possible, that is dividing AB, the interval AB, into more number of subintervals, we can get more accurate value by this approximate method. This method is a numerical method of calculating the integral of a given function, and this method is called trapezoidal rule. So if you like this video, please subscribe to my channel, like it, share it, and write a comment. In the next video, we will try to solve some problems using this trapezoidal rule. And in this trapezoidal rule, if this curve we have taken is a straight line, then accurate value we get it whether we divide more number of intervals or less number of intervals. Whenever it is a curve of this type, so then by taking smaller number of subintervals, that is taking large gap between interval to interval, that is taking h more and more, we get less accurate value. But when the number of intervals is increased by taking h smaller and smaller, then accurate value we get it. So in the next video, I will try to solve two types of problems in which the curve I take a straight line and show that the answer is very accurate, and by taking a curve of the type y is equal to x square or any other curve, the answer slightly differs. So before that, please try to subscribe to my channel. Thank you for watching.